Okay, so what I want to talk about in this lesson is the idea of an expression and then the idea of a slope. So if we take this expression, so y is equal to 3x plus 1. So this is an expression that we have here. Now we can look at this expression in relation to a graph. So here on this graph we have the x-axis and we have the y-axis. So really what we're saying, we are describing a line, for example. So we can look at this like so. So imagine we have something like this. Let me just draw this a little bit better. So we can have a line like this. So what we can say is there's a y value and then there's an x value. So imagine, and there's a relationship between these two. So if we take, so imagine, so the values along the x-axis are the horizontal values. So imagine we have the value 1. So we have the value 1. So when x is 1, what's y? Well, what we do is we have to put it into this function. So what we can say is that when x is 1, y is going to be equal to 3 times 1 plus 1, which is equal to 4. So when x is 1, so we can see here that we have taken our values. So we've taken this function and we've put in a value. We've put in a value into it. And what this does is it gives us the value for x. So when x is 1, y is equal to 4. So what about when x is 2? So when x is 2. Okay, so when x is 2, so what we can say is when x is 1, y is 1, 2, 3, 4. So y is up here. Okay, so this is the first coordinate, if you like. So when y is 2, sorry, when x is 2, what is y equal to? So we can look at it with something like this. So 3 times 2 plus 1. So 3 times 2 is 6 and plus 1 is equal to 7. So when x is 2, y is equal to 7. So we can see when x is 2, y is equal to 7. So we go up 3 more, 1, 2, 3. So when x is 2, y is 7. Okay, so it's somewhere here. So what about then when x is 3? So when x is 3, y is going to be equal to 3 times 3 plus 1. So 3 3s are 9 and 3 is, so 3 3s are 9 plus 1 is 10. So when x is 3, y is 10. We'll just do one more. So when x is 3, when x is over here, y is equal to, so this is 7, so y is 3 more up. So 1, 2, 3, so it's roughly up around here. Okay, so we can just work with these trees. So what we get here then is a straight line. We have a line that looks something like this. So it's going to go roughly through all these points. Okay, so it looks something like that. Now, also what we can say, what we can do, and when we look at this, so let me just straighten this up a little bit. So I can get it to, okay, so we're roughly getting through all of these points. So roughly going through all those points here. So what we can see, what we can kind of look at then as well, is that there's a rate of change in relation to these variables. So what is the change? So we can see that when x is 1, y is 4. So what's the difference between 1 and 4? It's 3. So when x is 2, y is 7. So you can see there that it is 5. Okay, and what's the okay, so actually not so much look at that, but if we look at this, okay, so what's the change between the y variables? So what's happening as we go? So we start off with 4, it jumps to 7, and then it jumps to 10. So you can see here, we can see there that there's a rate of change. So how is y changing? Well, it's changing by 3. So the difference between each of the numbers is +3. So we can see that y is increasing, but it's increasing by +3 each time. Now what we can actually do then is we can look at this. So this change here, or how y is changing in relation to x, is what's known as the slope. Okay, or the rate of change. Another way we can look at it is we can call it the function dy dx. Okay, this is what we can look at in relation to calculus. So it's the rate of change of y, or how much does y change each time x changes. So what does it go up by? So what we can say then is we can actually look at this if we were to, so imagine we could draw a line out here. So what we can see if we draw a line here like so, okay. So as we go across by 1, we're roughly going up by 3. Okay, so we kind of have like a triangle. So we go across by 1 and then we go up by 3. So what we can call this the run. So as we go across, and then we can call this the rise. And the slope then, or the dy dx, is equal to the rise divided by the run. So in this case, the run is equal to 1 and the rise is equal to 3. So therefore, if we look at it in this specific example, as we go across by 1, we go by 3. So that's 3 over 1, which is equal to 3. So therefore, the rate of change, or the dy dx, is equal to 3. So what we're looking at here is what's this 3 here, or this rate of change, is called the slope. And another way to kind of think about it is it's how as we increase in value, as the x value increases, what happens to the y value? The y value increases, and each time it increases by 3. So we start off with 4, then it goes up to 7, then it goes up to 10. And what we can find out then with this slope is that as we move along, we can see that it's just going to keep going up by, it's going to keep going up by 3. And we can see here that that indicates that, well, it shows us in this case that we're dealing with a straight line. So this expression here, what it actually describes this straight line. So we can see as we go up, so if it's 4, the value is going to go up by 3 again, so it's going to be 13. If it's 5, the value is going to go up by 3, it's going to be 16. If it's 6, the value is going to go up by 3, it's going to be 19. If it's 7, the value is going to go up by 3, so it's going to be 22. So the slope, what it really enables us to do is it enables us to see the rate of change, or how is this number, or how is this value for y, how is it changing? And this slope is used to describe the rate of change, for example, of a straight line. So again, if you want to calculate the slope, you need to find out what the run is. So what's the rate of change of the x value? So we can see here the rate of change of the x value is 1. So it's going up by 1 each time. This is what is called a run. We can look at it like this. And we need the rise, okay, or how is the y value changing? So we can see that it's changing by 3. So all we have to do is to divide these two by each other. Divide the rise by the run, and that's in this case it's 3 over 1. So therefore the slope, or the rate of change of y in relation to the change in x, is what's known as the slope, and that's equal to 3. So hopefully that makes sense. So again, this is just the idea of the slope.